at the Connectivity Pod on the Future booth at Embedded World 2022. I'm here with Rabee, who is our connectivity expert. Now, Rabee, you've got a lot of cool demos going on here. Can you tell me what we're showing and why we're showing it?
Yeah, thank you, Lorna. So, why we are here first, because meeting customers, and we are very, very successful today. And the past 2 days, we have a lot of customers coming in to hold the pod. Now, what is capturing the eyes on my customers was, in fact, what we call the RTLS, real-time location system, which means having services related to the position of an asset, of a machine inside a factory, inside a warehouse, or even for some consumer where I can have some follow me application and nice stuff coming. And this is related to the trend that is taking place on the market when it comes to automotive, like securing the car door opening with the distance measurement verification of the driver identity in front of the car, or also with the nearby interaction launched by Apple with the phone, so I can bring services to my accessories inside the house using my smartphone. So this year I decided to focus about the RTLS concept, and I am presenting 3 technologies, telling the customer there is no ideal solution. We need to choose the best solution for my use cases. So the first one was using BLE. So here we have the anchors using AOA BLE 5.0 or Bluetooth 5.1, sorry, using using 5.1 Bluetooth SIG standard. Here we have the advantage to use low power concept and using also a stable stack, which means the maintenance of the stack is done by Bluetooth SIG and customers should not worry about it. Just use the application level and the services provided by the stack. Drawback on this technology, we will have some cost on the infrastructure and we'll have some limitation on the precision. We will be around the 1 meter of that. So if the precision is not important for the customer, the power consumption is very low, then the AOA is the right technology. Right. The second technology, which is also BLE based, but now we are not speaking about the standard, we are speaking about proprietary protocol. So here I am using point to point, and you see it is fast, moving back and forth. Yep. And this technology, in fact, based on a proprietary protocol, which means I am using the BLE stack as a standard, and then I'm putting on top of it some proprietary signals that will travel back and forth and then make the round trip measurement. So I am winning on the precision because I can drop it down to the 50 centimeter level and still winning on the power consumption. The drawback is that I'm doing only point to point, so I need to multiply the number of these and I will be losing time. So if real time on the RTLS is not important, this is the best technology I can use. The last technology, and here you can see it on the screen, is ultra-wideband. Ultra-wideband is a radar pulse technology proposing precise positioning measurement. And here, in fact, we have the precision down to the 10 centimeter, and we have the fastest ever because it's like speed of light. So here, I am not running away from the camera. I am putting the tag on my hands, and I have the reference point we called anchors on the top, and I will be moving away from it, and you can see on the screen So the ultra-wideband is bringing the high precision down to the 10 centimeter level on the positioning, and also a real time because it's a speed of light pulse that is traveling over the air, measuring time of flight. So what are the drawbacks? Because each technology has in the drawback. We have an infrastructure indeed to be installed, to be synchronized, and this infrastructure is also something, the best it is synchronized, the best the precision on the position will be. Now, the second drawback is the power consumption. So the technology, when it is receiving, it's consuming more than the BLE, so we have relatively higher power consumption, but we cannot reach the precision without this technology. So how we can manage these different solutions, it's by hybridization We need to find the right word, by the way. So it is in fact to build a kind of hybrid system between this technology, which means I can use Bluetooth when I don't need high precision. Then once I need the precision, I can trigger as precise ranging using the ultra wideband and then stop it. And this we will be winning a lot on the power. A second thing we can think about is to make a hyperspace in the place, which means I have now the spatial awareness around me thanks to the ultra wideband. So in this area I have some density, so I need to go to in fact precise measurement, and that I don't have, so I can switch to another technology. So mixing the technologies and the spatial awareness is something helping our customers to win on the power consumption, win on the precision, and win on the asset tracking, the application to follow the workers without spending a lot of efforts, and also to protecting the customers. Protecting means if I have a heavy machine, I can control the distance between the worker and the machine and not have an accident.
Yep.
I can also make, in some, like say, pandemic situation, social distancing, I can control the distance between machine to machine or asset to asset, whatever. So these technologies are bringing safety, are bringing success to our customers. So we have different suppliers, we have a multiple, let's say, solutions, starting from the chip down design up to a solution. Our solution is scalable. Come and see us. We will be helpful when it comes to the RTLS.
Thank you very much, Rabee. Thank you.